Welcome to day 6 of our 62-day low-level design course. Today marks a pivotal point in our design journey as we begin building the real structural backbone of any object-oriented system, classes and interfaces. Designing them well is not just about syntax, it's about clarity, responsibility, and long-term maintainability. Whether you are working on a small utility or a complex enterprise system, strong class and interface design is what transforms good code into great architecture. Let's get started. Before we dive in, here's what we will take away from today's session. First, we will learn the core characteristics of a well-designed class, what to aim for and what to avoid. Second, we will explore how interfaces provide abstraction, allowing for flexibility, reusability, and testable code. Third, we will revisit the single responsibility principle or SRP and see how it keeps classes focused and easier to maintain. And finally, we will look at class relationships, how objects interact, depend, or extend one another. By the end, you will be equipped to design your own modules that are not only correct but clean and scalable. Let's start with the basic question: what exactly makes a good class? A good class encapsulates both data and behavior in a logical, self-contained unit. It should not just hold state, but also define how that state changes. It should have high cohesion, meaning it should only do one logical job. This makes it easier to understand and modify. It should also have low coupling, meaning it does not depend heavily on the internal workings of other classes. The less your class knows about others, the easier it is to change, reuse, and test in isolation. Think of each class as a self-reliant, single-purpose machine. It does its job and communicates cleanly with others through well-defined interfaces. The single responsibility principle is a cornerstone of good design. It states that a class should have only one reason to change. That means each class should focus on one responsibility or concern. If your task manager class is also logging errors, sending notifications, and updating databases, it's doing too much. Instead, you should break those responsibilities into focused units. Have a logger, a notifier, and maybe a repository. This separation makes your code easier to test, extend, and debug. Classes with multiple responsibilities become harder to maintain over time because changes in one feature can accidentally break another. SRP helps us guard against that risk. Now let's differentiate between interfaces and classes. An interface defines what needs to be done, while a class defines how it's done. This distinction is powerful. By programming to an interface, not a concrete class, you gain the flexibility to switch implementations without changing client code. For example, a payment processor interface can have different classes like credit card processor, PayPal processor, or UPI processor. This also supports dependency inversion, one of the solid principles, which states that high-level modules should not depend on low-level modules, but both should depend on abstraction. Interfaces make your system extensible, modular, and test-friendly. Classes don't live in isolation, they interact, and understanding how they relate to one another is key. Association is a general connection one class uses another. Aggregation is a has a relationship, but both objects can exist independently. For example, a university has students, but students can exist without the university. Composition is stronger. If one object is destroyed, the composed objects are too. Think of a house composed of rooms. Remove the house, and the rooms no longer make sense. Inheritance, on the other hand, creates an easy relationship. A dog is an animal. It allows for polymorphism, but should be used carefully to avoid tight coupling. Knowing when to use each relationship helps you architect clean, expressive systems. Designing interfaces well is more of an art than a science. Always try to keep your interfaces focused and minimal. The interface segregation principle reminds us that no client should be forced to depend on methods it does not use. If your interface is becoming too large, break it down. Also favor extension, add new interfaces over modification, which can break client code. Use interfaces to decouple your business logic from the actual implementation. It will make your code much easier to mock and test. And finally, avoid creating God interfaces that try to do everything. They are hard to implement and hard to maintain and violate several design principles at once. Let's look at a code example to reinforce what we have discussed. Here we have an assignable interface with a single method, assigned to. Then we have a task class implementing that interface. The task class holds a private user and provides its own implementation of assigned to. This design is elegant and scalable. Today, if we introduce a bug, event, or reminder, all of them can implement the assignable interface, each in their own way. This is how we build systems that are extensible without changing existing code. Now it's your turn to apply what we have learned. Your task is to design a simple task management system. Define classes like task, user, project, and status. Think about what behaviors can be abstracted into interfaces, maybe assignable, trackable, or prioritizable. Create a UML diagram first to visualize your design and then bring it to life in code. Don't worry about making it perfect. Focus on clarity, separation of concern, and applying SRP. For today's assignment, you will design an online quiz platform. Identify the key entities like question, quiz, user, submission, and so on. Think about which classes should interact, which behaviors belong in interfaces, and how to apply SRP. Your submission should include a UML class diagram and a short write-up around 300 words explaining your design choices. This is your opportunity to showcase your understanding of modular class design, abstraction, and system organization.